Question 9. The diameter of a circle center O is 26 centimeters. That's the diameter. If a chord PQ is drawn such that it is 5 centimeters from O to the center of the chord, calculate correct to the nearest O number the angle POQ, and B, area of the minor segment formed by the chord PQ. Take pi to be 22/7. Now there's one thing I want you to note here. If a chord PQ is drawn such that it is 5 centimeters from O to the center of the chord, this is telling you something. So let us mark it out. In the course of solving this question, we'll tend to see what this means. Now let's go back to the question so we can start turning our data or the information into a diagram as required by the question. It says here the diameter of a circle with center O is 26 centimeters. So we have to draw our circle first, then at the middle we make our diameter. We have it as this. Now that we have our circle, we now make the diameter. We'll draw a line right from the center to make our diameter. I'll know our D is 26 cm. Now it says if a chord is drawn such that it is 5 centimeters from O, which is the center of the circle, to the center of the chord. What this line is saying is that a line from the center, let's say this is our center O. What it's saying is a line from this center O that strikes a chord at the center makes an angle 90 to the chord. We should put that in note, so we have it here. So this is our chord and this is our diameter, and from the center to this side is the radius, same as this, from center to this side is the radius. We have our chord here. In dotted lines we make it 5 centimeters, and this makes an angle 90 because it divides the chord into 2 equal parts. Now calculate correct to the nearest O number the angle POQ. So we know our chord is P here and Q here. Now we've been asked to calculate the angle at O here to P and to Q. So we have to draw a line from here to P and another line from here to Q. The line from O to P is also the radius, because from center to P is the radius, and same from O to Q. So that's what we're drawing next. We're drawing the line from O to P and from O to Q to make the angle POQ. That's at O. We've been asked to find this angle, and we know this is 5 cm and this is the radius and this is also the radius, and we know our diameter is 26, and you know half of our diameter is the radius. We're not given directly our radius. To find this angle we need our radius and distance from the center of the circle to the center of the chord. This is like the height and this is one side. So what we're doing is, what we're going to use to solve this question is to use Pythagoras theorem. So we have this right angle triangle here, and for us to find this full angle we can't just find it directly. We need to find this small angle, then we now find the total angle. If you're very used to chords and finding lines and angles in chords, you will know what works with chords is Pythagoras theorem. So we apply Pythagoras theorem to solve this question. Now we have the big triangle, we're not using it. We need just this half of the triangle, which is the right angle triangle, to solve this question. As said, we know we can't just find this big angle once, because to find this angle, apart from Pythagoras theorem, we can use cosine rule or sine rule. And for us to use sine rule, we need this side and the base line or the base of the triangle. But we have this side and we have 5 in the middle. So we can't use that, so we improvise and use the right angle triangle to find this angle first, because this line divides this angle into 2 equal parts. So when we find this angle, we also know this angle is the same as this. So if this angle were to be 20, this is also 20. So the total angle will now be 40. So let's find this angle first. And we're told to find our answer, calculate to the nearest O number. We're told to calculate our angle to the nearest O number. So we'll start by finding this angle. And with what we have, this is the opposite, because it is the side facing the angle. So we have this as opposite. We have this line facing the 90 degrees, we have it as the hypotenuse. And the last is our adjacent. and with the hypotenuse and the adjacent we can find the angle. We don't need to have the 3 sides, we just need 2 sides and the angle we're looking for. So what combines hypotenuse and adjacent? We know of the Pythagoras theorem, it is cos theta that combines the hypotenuse and the adjacent, which is adjacent over hypotenuse. That's cos theta is adjacent over hypotenuse. With that we can find our angle, which is cos theta equals, our adjacent is 5 and our hypotenuse is 13. Cos theta equals 5 divided by 13 will give you 0.3846. Now since we're looking for theta, we go theta equals, this cos will now jump over the equals to sign and becomes anti-cos or arc cos. So we have cos arc 0.3846. Use your calculator and you can press either shift or second function cos, then you punch in 0.3846, then punch the equals to sign on the answer sign. It gives you 67.38 degrees. Since our answer is wanted in whole number, we have it as theta equals 67 degrees. So this is to the nearest degrees 67, because 3 is not even up to 5. So by the time you are taking off these two through approximation, it doesn't add anything to the number in front. Theta is 67 degrees. We know theta is 67 degrees, and we've been asked to find this total angle, that's POQ. That's at O, we're asked to find this total angle, which is 67 times 2. We therefore know angle POQ is theta plus theta, or 2 times theta, or theta times 2, which is 2 times 67 degrees, which gives us 134 degrees. This is our final answer. Now this is what we have of our diagram, and the question says calculate the area of the minor segment formed by the chord. I want you to have something in mind. Imagine the next time I tell you calculate the area of the major segment. Let's just solve the minor segment as asked today. Now we know this is a sector. This shape we have OP, taking the arc or the curve to Q back to O is a sector, and this is the minor segment. This part of the shape is the minor segment, and this is the major segment. Let us shade the minor segment. This is the minor segment. Now, noting that this is the minor segment, and we're asked to find the area of it, and there's no direct formula to find the area of a segment. So we find the area of the sector, subtract the area of this triangle from the area of the sector we found, then we find the area of the segment. That means, let's say the area of this sector is 30 and the area of this triangle is 20. The area of this segment will be 30 minus 20, which will give us 10. It's like the area of the total shape is 30, then this part of the shape is 20, then the rest will be 10, because 20 plus 10 will give you the total area of the shape, which is 30. Let's put that in mind, that the way we can solve this is to find the area of the sector and find the area of the triangle, this triangle OPQ, and subtract the area of this triangle OPQ from the area of sector OPQ. Let's just put that in mind. So let's continue. Note that the diameter is no longer required because we just need the area of this. Now once we find the area of the sector, like I said, and find the area of the triangle, subtract the area of the triangle from the area of the sector. We can write it as area of minor segment equals area of sector minus area of triangle. Now we know area of minor segment AMS is equal to area of sector, which is theta over 360 times pi r squared, minus area of triangle. In this case we have two sides and an angle between the lines or the sides. The formula we apply here in this case is we use half AB, that's the two sides, sine the angle between them, which is angle C. Area of minor segment is, our theta we know is 134 degrees over 360 times, we were told to take our pi as 22 over 7, and pi is 22 over 7, and our radius is the distance from here to here, which is 13 times 13 squared minus half. Then you have your A is 13, your B is 13, and the angle between them is 134. So we have half 13 times 13 times sine 134 degrees. We have it as area of minor segment AMS equals 134 times 22 times 13 times 13, because this is 13 squared, so we take the numerator, all the numbers on top first. We can say this is 13 squared over 1. At the base we have 360 times 7, so we'll have it over 360 times 7 minus, on this other side we can make this 13 over 1, 13 over 1, and this over 1. On this side we have 1 times 13 times 13 times sine 134 degrees, so we have it as 13 times 13 times sine 134 degrees to 4 decimal places is 0.7193 over, we have at the base or the denominator 2 times 1 times 1 times 1, that's 2. Our AMS, that's minor segment, you multiply the numerator at this point, 134 times 22 times 13 times 13 will give you 498,212 over 360 times 7 is 2,520 minus, you have 13 times 13 times 0.7193 with our calculator will give us 121.5617 over 2. On the next line we have our area equals, we have 498,212 divided by 2,520, which will give us with our calculator 197.7 to 1 decimal place minus 121.5617 divided by 2 will give us approximately 60.8 to 1 decimal place. Our AMS, area of minor segment, is 197.7 minus 60.8 will give us 136.9, and the answer is said to be wanted in whole number, so we have it as area of minor segment is 137 centimeters squared. Remember to put your units so you can get your full marks. So this is it. We know the area of our minor segment is 137 centimeters squared. Now we know Waec is dishing out some very technical questions. Now come to think of it, what if Waec asks you in this kind of question to find the area of the major segment in the next coming exam or in the upper one? Well, to find the area of the major segment, you can't find it directly. You need to find the area of the minor segment first, then subtract the area of the minor segment from the area of the total circle to get the area of the major segment, which is this part of it, this whole area. That's the major segment, this is the minor one. Area of major segment, you can make it capital letter M, equals area of circle minus area of minor segment, small letter m, to know the difference between the major segment and the minor segment.